I'll just briefly for each text, otherwise I'll take way too long. Now, if you've been following this course consistently, then you'll remember I thought I would I'd get a kind of mini course inserted in the middle of this one, probably at the end of part 2 of the text. Remember, this course has 3 parts. The textbook has 3 parts. So part 2, which we're into now, is called computability. Let me check. Computability theory. Okay, so there are 4 chapters in that part, and we've just finished the first of those 4, which is on the ChurchTuringThesis. So next we get into decidability. So by the end of, and then chapter 5 is reducibility, and chapter 6 advanced topics in computability theory. So once we've finished chapter 6, then I'll branch off a bit and give you a kind of mini course based on this book on Gödel's proof. Now it's that's at sort of senior, probably senior level, but it gives you a good feel of what Gödel's proof is all about, which is so fascinating. So think of that as about senior level, more or less. All right, now at master's level, this one, computability and complexity theory. 2 authors, Stephen Homer and Alan Selman. Okay, so there's some overlap with the Sipser text, but that'll be at M1. It's at higher level, so it's M1 level, master's level, and possibly, I don't know if there's too much overlap. I haven't fully decided yet, but now I've already actually used this textbook in China for a course on theory of computation. So you can just see elements of the theory of computation. 2 authors, Lewis and Papadimitriou, Greek name I guess. Right? It's not too long. What's that, about 200 pages? Ooh! Thin paper. Oh yeah, I forget. It's Chinese version. They tend to have very thin paper, lower quality. So it's 350 pages. So M1 level, maybe, if there's not too much overlap. With a different emphasis, Computation, Finite and Infinite Machines by Marvin Minsky, one of the fathers of artificial intelligence, again at MIT. I've shown you this book before. How many pages? 300. Okay, so it talks a bit about neural nets as well. So the infinite machines referring to Turing machines. I think he also does Post. Post is another guy like Turing. Yeah, Post normal form. So if you're interested in Turing machine, like Sipser doesn't go into Turing machine theory very much, or nor the programming of it. So if you want to do that, so this book would be sort of complementary to Sipser's book. So I'll probably teach that one, and I know Minsky quite well, many times. All right, now this one it's logic. Mathematical logic, and it's a bit fringy in terms of theory of computation, but remember the intimate links between the creation of the general purpose programmable computer and its historical origins, which are tied up with the foundations of mathematics. And people were using logic and set theory to as the foundations of mathematics, and out of that came the computer. Okay, So this is a book on mathematical logic, and it includes like undecidable problems, Gödel computability, Turing or Markov algorithms, ordinal numbers, axiom systems, recursive undecidability, Gödel's theorem, arithmetization, Gödel numbers. So, fascinating stuff. Okay, that's all at M1 level. Okay. Now at M2 level, things get a bit harder. Now I've shown you this one before. So computability and unsolvability. So that's well, it's two. Well, Sipser M1. Like next chapter, chapter 4 of the Sipser text, we're pretty effectively M1 level, I'd say. So this is quite a bit harder. So I'd say M2 level by Davis, and I have another book at PhD level, PhD 1 level, also by Davis, harder again. But this you can just see from the title. So this is at a higher level of abstraction of material we'll do next chapter. Okay, and I've shown you this before. There's an appendix in it on Hilbert's 10th problem. 30-odd pages proving that Hilbert's 10th problem is unsolvable. Okay, so M2. Complexity theory. Now, part 3 of Sipser's text is on complexity theory. Complexity theory talks about the level of hardness, like how much effort is involved by a computer to solve a particular problem. Now, complexity theory is in a sense a subset, a branch of computability theory. It's complexity theory assumes that the problem can be solved. Right? So in that sense, it's a subset of all problems. Some problems cannot be solved, and that's what computability theory is about. And of those that can be solved, complexity theory goes on to ask the question: well, how readily can those problems be solved? How easily? Are these problems fairly simple? Require not too many computational steps by a computer to solve them, or not? Some problems are just hard, meaning involve huge numbers of steps. That's what complexity theory is about, and it's a blossoming area of research at the moment. A lot of effort going into this complexity theory. So that's M2 level. Similarly, another by the same author as one of the texts at M1 level, Papa Dimitriou, but as single author. So again, complexity theory. You had to choose a different title, so we just chose computational complexity. This is maybe M2 PhD 1 level. It's quite a bit harder. Right, now I haven't quite decided, but you can see here I've got 5 books on set theory and mathematical logic, like Introduction to Axiomatic Set Theory, an algebraic introduction to mathematical logic, a course in mathematical logic, axiomatic set theory. So set theory and logic, mathematical logic, are closely related to theory of computation, because that's where computers came from, and Gödel's theorem, continuum hypothesis, that kind of stuff are all intimately linked, and it's just fascinating in its own right. I mean, well, it depends on your tastes, of course, but if you really like math and foundational questions about mathematics, with deep philosophical consequences, if you like that kind of stuff, then you may like several of these courses that I'll give. When I see something as thick as that, now this is thin paper. How many pages is this? 500 pages. So this is my finger to compare. That would take ages, many months. So debatable. But anyway, that's M2 level. Now at PhD 1 level, there's quite a transition. How do I put this without being blunt? I don't think I can. If you are at master's level, you know full well that you were highly filtered, you were selected to get from bachelor level to master's level. Now, of the several universities I've been a professor at, I would guess, I don't know, a fifth maybe? Some university, good university, maybe a quarter. Most universities that have a master's program, maybe it could even be as low as a tenth, somewhere between a fifth and a tenth of bachelor students go on to do masters. I'm a bit fuzzy on the fraction because I don't have a lot of experience with, and I haven't seen the statistics. But still, there's quite a bit of filtering that's going on between the bachelor students and the master's students. The master's students are definitely brighter. I had a first-hand experience with that. I've mentioned in earlier sessions, boards. When I was a prof in China, before I retired, I gave a theory of computation course to a mixed group, a mixed class of seniors, in other words undergrads, and first year masters level. Now,